All right, now we're going to get into the good stuff with Kepler's third law. I just want to remind you what it is. T squared over r cubed equals a constant for anything orbiting the same bodies. I'm just going to focus on planets now. So t squared over r cubed equals the same number for all planets in our solar system. Anything orbiting the sun, so that includes dwarf planets, asteroids, comets. And we can use whatever units we want as long as they match, like in the example we just did with Mars's moons. Okay, I'm going to show you how smart we can be with this. So I've kind of sketched the inner planets here. Let me get the sun involved. Okay, so Mercury, Venus, Earth, Mars. The sun is certainly not to scale. The distances for these three are pretty close, but that doesn't matter. Okay, so the orbital radius of Earth is 1.49 times 10 to the 11 meters. We know that that changes depending on where it is in its path around the sun, but that's the average value, and that is the orbital radius. Now, let's talk about t squared over r cubed. The orbital period of Earth is 1 year, and we're allowed to use years, Earth years, as our unit. R is this. That's not a very nice number. If we want to use our period of 1 year, it would be nice if R was a good number too, like 1. But here's the deal, we're smart people and we're in charge. We can make this equal to 1, and we have. This value, the distance between the sun and the Earth, we define that as 1 astronomical unit. And that symbol is AU. So the Earth is, on average, 1 AU from the sun. So if we use AU as our units, check this out. T squared over r cubed equals 1 squared over 1 cubed. That equals 1. If T is in years, Earth years, and R is in AU, astronomical units. I'm going to show you why this is useful. Okay. This is Venus. I could write its orbital radius in meters, but I don't know what it is. I do know that it's about 72% the way, 72% the full distance from Earth to the sun. So this is Venus. If it's 72% as far, that's 0.72 AU. That's why I like AU so much. Mars is at about 1.52 AU. All right. So just knowing that, we can very quickly find some cool stuff out. Let's find the length of a Venusian year, a year on Venus. So that's its orbital period. We can just say t squared over r cubed equals 1. We know what r is in astronomical units right here. Okay, so t squared over 0.72 cubed equals 1. So the orbital period of Venus is just going to be the square root of 0.72 cubed. I get 0.61. That's years. Earth years, of course. So if you want to impress your friends, oops, something happened there. Let me get that back. Okay, so that's the number of Earth years Venus's orbital period is. If we multiply that by days, like in a year. So Venus's year is about 223 days. That's cool.